Okay, probability. Probability is a measure of how likely it is that a particular event will happen. An event is a specific result or group of possible outcomes where an outcome refers to the result of a single trial of an experiment, such as rolling a die or flipping a coin. The probability of an event, written as P of event, can be determined in two ways, through reasoning based on known possibilities or by analyzing data from repeated events. Okay, is everyone familiar with a standard six-sided die? I don't think I have one. Okay, so if we were, say, calculating the probability of rolling an even number on a six-sided die, the event that we're calculating is rolling an even number. So when I say P of event in parentheses, I'm talking about the probability of rolling an even number. The sample space would be all possible outcomes. If we have a six-sided die, the possible things you might roll would be any number 1 through 6. And if our event is rolling an even number, favorable outcomes would be 2, 4, or 6, because 2, 4, and 6 are even numbers. Theoretical probability. Theoretical probability is calculated by dividing the total number of favorable outcomes by the total number of possible outcomes. This method assumes that all outcomes are equally likely. Okay, so going back to the example of rolling an even number. So how many possible outcomes are there on rolling a six-sided die? 6. How many favorable outcomes are there if we're looking to roll an even number? 3. So the probability of rolling an even number would be 3 over 6, which simplifies to 1 over 2. Does that make sense? Okay. So that's theoretical probability. Experimental probability is found by conducting an experiment using the ratio of the number of times an event actually occurs to the total number of trials. This method is based on observed data. Okay, so going back to rolling a six-sided die. Experimental probability would be like if I actually rolled a six-sided die. Yes? To here? Okay. So if I go to apps 0 and I'm rolling a die, and I roll it once, I got a 4. I'm going to roll it 50 more times, another 50 times, another 50 times, another 50 times. So I've now rolled the die 201 times. Let's see how many even numbers I got. Looks like I got 41 2s. I got 30 4s. And I got 36s. So the probability would be 41 plus 30 plus 30, that's 101. 101 over 200.
How do you get to that on the calculator?
So apps, we did this last class. You go to apps, and then you scroll all the way down to Prob Sim. Yeah, and then I did roll dice. Yes?
Can I see that page?
Yeah, I'm going to. Any other questions? All right, so what we would have is 101 divided by, 201, which is not exactly 50%, but it's pretty close. What you'll find in experimental probability, that the more times you do the experiment, the closer and closer you'll get to theoretical probability. So if I only roll the dice 6 times, I might roll each number once, but probably I'm going to roll a number 2 or 3 times. But if I roll a dice 1,000,000 times, I'm going to get pretty close to 1/6 1s, 1/6 2s, 1/6 3s, 4s, and 5s, and 6s. Okay, any questions on the definitions? Okay. You don't need to ask, just sign up. Okay, going on to odds. I'm sure you guys have heard odds before. Like if you go to a horse race and it says the odds in favor are 3 to 1, the odds against are 2 to 1, something like that. Does anyone need a few more seconds on this page? You got it. Anyone need a little bit more time? Okay. Yes.
Since I was out the other day, how can I catch myself up on the notes that I missed?
You can either get them from a friend or watch the YouTube videos that are posted. I recommend copying from a friend because it's faster, but if you're copying notes and you're like, I'm not getting what's going on, then watch the video. Okay. Sometimes it's easier when you see everything done out over time. But the video is like the length of a class, so it's a little bit longer. Of course, you can fast forward, pause, that sort of thing. Okay, anyone still copying things down? All right, I'm now turning the page to odds. Okay, odds provide another way to express the chance of an event happening, comparing the number of favorable outcomes to the number of unfavorable ones. Okay, so what's really important here, when a problem asks you for odds, you're not going to look at the total number of possibilities at all. You're only going to look at the number of favorable outcomes and then the rest of the outcomes, the number of unfavorable outcomes. So for example, back to our dice rolling thing, the odds of rolling an even number. There are 3 possible favorable outcomes for even numbers, and then there's 3 unfavorable outcomes, basically 1, 3, or 5. So the odds in favor would be 3 to 3, which simplifies 1 to 1. If I was to say instead, what are the odds in favor of rolling a number bigger than 4? Well, there are 2 numbers bigger than 4, 5 and 6. So the odds would be 2 to 4, because there are 4 numbers that are not bigger than 4. So 2 to 4 odds in favor, or 4 to 2 odds against. But you would simplify that 1 to 2 or 2 to 1. All right. A compound event involves 2 or more events happening together or in sequence, and is typically joined by the words and or or. If 2 events cannot happen at the same time, meaning they share no common outcomes, they are called mutually exclusive events. On the other hand, overlapping events have 1 or more outcomes in common that can occur simultaneously. All right, so this would be like if I said, what is the probability of rolling an even number or a 5? Is it possible to roll an even number and a 5 on the same roll? No, because a 5 is not an even number. You're either going to roll an even number or you're going to roll an odd number. You're not going to do both. So those 2 events, rolling an even number and rolling a 5, those are mutually exclusive events because it is not possible to do both of them at the same time. Does that make sense? Now, if I said the probability of rolling an even number or the probability of rolling a number bigger than 4, is it possible for both of those things to happen? Yeah, you could roll a 6. A 6 is bigger than 4, and a 6 is an even number. So those would be overlapping events, because it is possible for both of those things to happen. So there are two different equations you would use depending on if your situation is mutually exclusive or overlapping. If you have two mutually exclusive events, events that can't both happen, and you're trying to solve the probability of this or that happening, you're going to find the probability of event A, find the probability of event B, and add them together. And that's your answer. We will do an example. If you have overlapping events, events that could both happen, you start out the same way, find probabilities of A and B, but then you're going to subtract the probability of both of those things happening. Last set of definitions. When examining how one event affects another, two events are independent events if the occurrence of one does not change the likelihood of the other happening. Conversely, they are dependent events if the outcome or occurrence of one event does influence the probability of the second event. Okay, are you guys familiar with a standard deck of 52 cards? You guys all know what a deck of cards looks like? So a deck of cards, there's 52 of them. There's 4 suits, 13 of each suit. Let's imagine I shuffle a deck of cards, and I'm going to randomly draw a card, and I want to calculate the probability of drawing a club. The probability of drawing a club would be 13 over 52, because there's 13 clubs, and there's 52 cards total, right? And you simplify that to 1 out of 4. So let's say I shuffle my cards, I draw a card, and it's the Queen of Hearts. Not a club. And now let's say I put that card on the side, and I draw a second card. That first draw affects the probability of the second draw, because now I don't have 52 cards, I have 51 cards. And I'm down 1 heart, because I drew the Queen of Hearts. Okay, so those would be dependent events, because the first event impacts the second event. Now, if instead I shuffled the cards, I drew the Queen of Hearts, and I put the Queen of Hearts back in there, and I shuffled again, and then drew a second card, now those are independent events, because the first draw has no impact on the second draw. I put the card back in, I reshuffled it, so it's going to be the same probability the second time that it was the first time. So the only difference is, with independent events, you can calculate A and B and multiply them together. So if you're calculating both of these things happening, you're calculating probability of A times the probability of B. With dependent events, where like the card isn't put back in, or something where the first event does have an impact on the second event, you have to recalculate the probability of B given that A has occurred. And that will give you some different numbers. Alright, that's a lot of vocab. We're going to do examples of all these things. For the most part, I'm going to do an example, and then I'll give you guys one to try. Does anyone need a little bit more time to copy this down? Okay. Excuse me. All right, ready? Okay. Example number 1. A school library has 8 different genres of books: mystery, fantasy, science fiction, historical fiction, biography, poetry, graphic novels, and nonfiction. The genres have been arranged on shelves from left to right in that order, with mystery being the first and nonfiction being the last. You randomly pick one genre to explore for a book report. What is the theoretical probability that you select a genre that is shelved to the left of biography? Okay, so we're trying to find the probability that you're going to randomly pick a genre to the left of biography. How many genres are to the left of biography? 4. How many genres are there total? 8. So the probability would be 4 over 8, which simplifies to 1 over 2. Is it really warm in here? No, it's okay. I'm going to dim the lights a little bit. Is this too dark? No. Okay, it might be just that the light is really close to my desk. I'm getting warm. Do you guys feel like you could do one like this? Let's do it. Okay, it looks like I forgot to leave blanks in all the practice problems. My bad. It says, at a local art shop, 50 attendees are each randomly assigned a type of art project to complete. There are 20 painting kits, 10 drawing kits, 10 sculpting kits, and 10 collage kits. What is the probability that a participant does not receive a painting kit? Please give me your answer in simplified fraction form on your whiteboard. When you have it, please hold up your board. Yep. Once you get it right, please check in with your teammates. Make sure everyone at your table understands. And ask each other questions, help each other out. If there's a question no one at your table can answer, call me over. Yes. Yes. Team 4? Should just shout it out. Yep. Everyone got it. Great job. So, basically, if there are 20 painting kits, 30 of them are not painting kits. So 30 out of 50 equals 3 out of 5. Any questions on this practice problem? Okay, let's do some problems with odds. What are the odds of rolling a number greater than 4 on a standard 6-sided die? All right, how many numbers are greater than 4 on a 6-sided die? 2, right? 5 and 6. How many numbers are not greater than 4? 4. So when you're dealing with odds, you're not going to have the total number of possibilities at all. But the odds in favor and the odds against should add up to the total number. So in this case, our odds are 2 to 4, odds in favor, which simplifies 1 to 2. Typically, odds are written like this. A 1, or a number, a colon, and another number. But you simplify them just like fractions. All right, take a look at the practice problem. I made some changes, but they should be updated on your packet. This was my rough draft. Do you guys feel like you can do this? Yes. Okay. Talk to your teammates. When you think you have an answer, please hold up your board. Did you do these previously, or are you doing them now?
I did these because I thought it was helpful.
Okay. So let your teammates answer that. Okay. And that's why I usually leave blanks so that people don't do that.
Oh yeah, I didn't do the one with the blanks, but
yeah, I forgot to leave blanks on this one. It's my bad. No, sorry. So you're looking at odds against. Nope, sorry. An even number less than 6, right? So not 6. No, it should be a number, a colon, another number. Nope, sorry.
does it just stay?
Nope, sorry. So guys, what is how many even numbers are there less than 6? 2. And then how many numbers on the die are not even numbers less than 6? 4. Use that information. Everyone's giving me like 1 to 3 or 1 to 2. I don't know how you're getting that. And remember, it's odds against. So it's unfavorable, favorable. Yep. Good job. Talk to your teammates. Make sure they get it too. Well done. Nope, sorry. I don't know how you're getting 3. Because you're not using 6, right? Nope, sorry. So that's right, but it's not simplified. Yep. All right, I'm going to give you guys 45 seconds, and then we got to go over it. You guys got an answer? No? So how many even numbers are less than 6? 2. Can you keep your head up, Alana? Okay. And how many are the rest of the numbers possible? There's 6 total, so how many? 2 of them are favorable. How many are unfavorable? 4. So 4 to 2. Okay. 2 to 1. Okay. Here is the answer. Okay. We said that there are 2 even numbers less than 6, 2 and 4. And then there are 4 other numbers. Remember, when you're dealing with odds, these 2 numbers should add up to the total. So if you know that there's a total of 6 numbers, if this is 2, this one needs to be 4. And then you simplify. The only difference between odds and odds against is that this is odds in favor versus odds against, and this is switched. Yes? Odds against. Yeah. If you're dealing with odds against, that's going to be the case. Any other questions on this problem? Okay. All right, example number 3. We're now going to do an example of experimental probability. This says, after getting reports of issues, a company randomly inspects 1,000 backpacks from a recent shipment. They find that 989 of them are in perfect condition. What is the probability expressed as a percent that a randomly selected backpack has no defects? Okay, because this is experimental probability, we're going to look at how many times was this done. Well, they inspected 1,000 backpacks. That's our bottom number. And then they want to know what's the probability of having no defects. Well, how many of those 1,000 backpacks had no defects? 989. So you have 989 divided by 1,000, and that equals this. This is the decimal form of the answer, but they want the percent. How do you convert a decimal to a percent? You multiply by 100, or you move the decimal 2 places to the right. There you go, 98.9. So there is a 98.9% chance that the backpack has no defects. Any questions? Do you guys feel like you could do one like this? Okay, this next problem takes things a step further. We're going to solve it in steps. For this first step, I just want you to tell me the percent. Okay, so let me see here. You survey 500 randomly selected restaurants in your city to find out if they offer vegetarian options. Of the 500 restaurants, 197 respond that they do offer vegetarian options. If your city has 24,800 restaurants, about how many restaurants are likely to offer vegetarian options? Okay, ignore the 24,800 for now. For now, I just want to know what is the percent of the 500 restaurants that offer vegetarian options. When you have that answer, please hold up your board. Give it to me as a percent.
There's 500 restaurants, and there's only 100
Yep. Good job. Yes. Yes. Yes.
I didn't solve it for her.
Yes. Everyone got it. You guys are awesome. Here is the answer. So we have 197 over 500. If you divide that and then multiply by 100, you get 39.4%. Are there any questions on how we got that? Okay, now this question asks a follow-up question. It says, if your city has 24,800 restaurants, how many restaurants are likely to offer vegetarian options? I'll give a bonus point if someone can raise their hand and tell me just basically how you would go about solving this. Yes?
Is it 24,800 divided by 39?
It's a good guess, but no. Yes?
I would times the percentage with 197.
The percent or a different form of the percent?
Like the decimal form.
Very good. Good job. All right, so that's exactly what you want to do. Basically, you want to find what is 39.4% of 24,800. Like, how do you find 39.4% of this number? You multiply it. This, you keep it in its decimal form, not its percent form. Keep it in its decimal form and multiply it by this number. Go ahead, and when you have your answer, please hold up your board. Yes. I'll give you guys one more minute. Yes.
When we're you wanted to be
Yep, keep it in decimal form. You guys have about 30 seconds. About 30 seconds. Yes, don't put the 0.2. So you're going to round to the nearest restaurant because you can't have 0.2 restaurants. Yes. Team 2, you guys have an answer? What are you doing? All right, let's go over this. Okay, so 39.4% written as a decimal is 0.394. Multiply that by the total number of restaurants. You should get 9,771.2, but you can't have 0.2 restaurants, so we're going to round to the nearest whole restaurant. Are there any questions on this problem? All right, let's do another type of problem. Okay, so these next couple problems have to do with mutually exclusive and overlapping events. The last few Algebra 1 blocks, they got a little hung up on the notation, so I'm going to do a little bit of work on the whiteboards just to help mitigate those confusions, but please let me know if you need more explanation. I'm going to do the first two, and then I'll give you guys a couple to try. It says, what is the probability that you spin a multiple of 3 or a 10? And we're spinning a spinner that has 12 equal-sized sections numbered 1 through 12. All right, so we have this spinner, and all the possibilities are the numbers 1 through 12. And it says here, what is the probability that you spin a multiple of 3 or a 10? So my event A is a multiple of 3. My event B is a 10. So the probability of A or B, if you remember, there were two equations that we might use for situations like these. We first need to figure out, are these mutually exclusive or are they overlapping? Which of these numbers are multiples of 3? Shout out. 3, 6, 9, 12. Perfect. So 3, 6, 9, and 12. And then event B is the 10. Is it possible for both of these things to happen? No, because 10 is not a multiple of 3. So these are mutually exclusive. So the equation we're going to use is the probability of A plus the probability of B. Okay. A is multiple of 3. What is the probability that we spin a multiple of 3? 4 out of 12. 4 out of 12. Perfect. Okay, somebody else. What's the probability that we spin a 10? There's 1 10. Oh, 1 out of 10. There's 12, because there's 12 total. 1 out of 12. So, as the numerators, I get 5 out of 12. Yeah. Make sense? Okay. Are there any questions on this? The next one's going to be an overlapping. So this is what you do if they're mutually exclusive. If it's not possible for both of them to happen, that's what you do. And I also wrote it up here. So some people were asking what amount of work would you need to show. Any of this is fine, but honestly, as long as you put this last part, 4 over 12 plus 1 over 12 equals 5 over 12, that's enough work for me. Okay, if it helps you to write all this stuff, or if it helps you to write all that stuff, do it. You know, it's better to get it right and spend a little bit more time, but that's not necessary if you don't need that. Okay. This is actually B. What is the probability that you spin either a multiple of 3 or an even number? Okay, let's go back here. My eraser has disappeared. Okay, so now we're looking to spin a multiple of 3 or an even number. 6. So, we first need to figure out, are these mutually exclusive or overlapping? I kind of already spoke of being that they are going to be overlapping. Multiples of 3, same as last time, 3, 6, 9, 12. Which of these are even numbers? 2, 4, 6, 8, yep. I'm going to underline them. So we've got 2, 4, 6, 8, 10, 12. There are some numbers that are both circled and underlined. That means there are some numbers that are both even numbers and multiples of 3. So these are overlapping events. So we're going to use this equation.
This is for B, right?
Yes. Okay, tell me, what is the probability of spinning a multiple of 3? 4 out of 12.
What's A and B? What do they stand for?
A is spinning a multiple of 3, B is spinning an even number.
Okay.
Okay, what is the probability of spinning an even number?
6 out of 12.
6 out of 12. Okay, somebody else. What is the probability of spinning a number that is both a multiple of 3 and an even number?
6? No, 2.
2. It's just 6 and 12. Those are the only two numbers that are both circled and underlined. So 2 out of 12. 4, 2 plus 7, there we go. 4 plus 6 minus 2 is 8. 8 out of 12 simplifies to 2 over 3. All right. How do you guys feel about these? Are there any questions that I can help with before I give you guys one to try or two to try? Okay, I'm going to give you one. We'll do one at a time, but these next couple problems are going to be either mutually exclusive or overlapping. First thing you're going to want to do is figure out which it is, and then use the appropriate equation. So practice. Suppose you roll a 6-sided die. What is the probability that you roll an odd number or a number less than 4? Please give me your answer as a simplified fraction. When you have it, please hold up your board. I'll give you guys 2 minutes. Nope, sorry. I think you might have included 4. So it's not less than or equal to 4. It's less than 4. Nope, sorry.
So you get it? Yeah. Okay, so what would the answer be? Yeah.
Yep. Teammates understand?
Yeah.
Great.
She got the answer. I just wrote it down.
Yeah, I just want to make sure you guys are helping each other out. Are those my scissors? Oh, sorry.
Yes.
So in this case, A is rolling an odd number and B is rolling a number less than 4. Can you simplify that? I'm adding one more minute and then we will go over it. Good job, Team 2. Make sure everyone at your table understands. You did great. I'm going to go over it with everybody, but there are 3 teams that haven't answered. If it was just you, I'd come over there, but there's 3 teams. Unfortunately, I can't go to 3 tables. It would take too much time. We only have 14 minutes left. Okay, so teams 3, 4, and 5. It looks like 1 or 2 of you are working, but most of you guys seem like you're not doing much. What's up? Well, what are the possible numbers on a 6-sided die?
6.
So 1, 2, 3, 4, 5, 6. Did you write that out?
Yeah.
Okay, and then did you circle the odd numbers?
Yes.
So 1, 3, and 5.
But it says less than.
No. It says roll an odd number or a number less than 4. Isn't that what it says?
Never mind. Can I have like one more minute?
Sure.
So what do we?
So it's just reading the problem carefully. Okay. All right. Here I thought. Well, I guess that's better than not understanding. Team 3, does that make sense to you too? Is that what you were having trouble with also? What can I do to help? I'm not okay with you guys just sitting there and waiting for the answer. Well, did you do what I did up there? Did you write out the numbers 1, 2, 3, 4, 5, 6? Okay, and did you circle the odd numbers? And then you drew underlines under the numbers 1, 2, and 3 because those are the numbers less than 4? Okay, what is the probability of an odd number? 3 out of 6, right? There's 3 odd numbers, and there's 6 total, right? Okay. How many numbers are less than 4? No, there's 3. 1, 2, and 3. All right, Team 5, you guys got something for me? Okay, let's see. What do you guys do? So you're going to use this equation. So you have to find, yes, that's correct. You have to find the probability of rolling an even number, the probability of rolling a number less than 4, minus the probability of rolling an odd number less than 4.
I got it.
Stop it.
Oh, but you guys are at least yeah, it'd be 2/3. Yeah. For the third beat, right? Yeah. So are these
Using that equation. Team 1, you guys already got the answer. Oh, we did? Yeah. So, the probability of rolling an odd number. What is the probability of rolling an odd number? What's the probability of rolling a number lower than 4? Less than 4. I did that. 6. You find the odd one. How many numbers are those? I got it too. I'm scared. No, we're on 8 in there. Okay, teams 4 and 5. Wait, did you guys answer? Yeah, who's the 5 answered? 2/3. Oh, I thought this was 10? No. I understand. I was getting to the last one there. Okay, wait, so it's like dark blue? I don't know what's it for. I don't know what to call it. It's like, for right here, like from the bottom. From the bottom. I'll send you a picture. First after you guys. And then I also like blue teams. Like they're usually 18. So after you have whoever's number 18. I do not know. I'm gonna write go Can All right. Everyone eventually got it. Good job. Here is the answer. Are there any questions on A? All right, please try this one. What is the probability that you roll an even number or a 5? Yeah.
Can you explain how do you know it's overlapping again?
So, if you do odd numbers, you have 1, 2, 3, 4, 5, 6, right? How many of these are odd numbers? 1, 3, and 5. How many of them are less than 4? Is it possible to be both odd and less than 4? Yes, then they're overlapping. So if it's mutually exclusive, it's not possible for both. All right. All right, when you think you have your answer, hold up your board. Yes, yes, good job. 5. Can you guys work on the problem? So, let them try it. Let them try it. You learn more when you try yourself.
I think I did it, but
Good for you.
I don't think it's right though.
I'll give you guys 1 minute.
Did I do it? Did I do it?
Your 3's backwards. It's not right. Did you do, how many are even numbers? And how many 5s are there? 3 plus 1 is 4.
Yes.
How'd you get 1 over 3? 4 over 6 does not simplify to 1 over 3. Yes.
Oh, 2 over 6.
Yep, team 1, good job. Team 3, got something?
So there's 3 even numbers again, and it was only. Oh wait, I did get it right though.
Well, is it mutually exclusive or overlapping? They're mutually exclusive because it's not possible to have an even number and a 5, right? So you just add them together, don't subtract anything. Which is? That's correct, but not simplified. Yes. All right, everyone got it? Great job. Here is the answer. Okay, the answer is 2/3. These are mutually exclusive. Are there any questions? Of course, I'll leave it up there. All right, we're just going to work all the way to the bell. Whatever we don't finish, we'll do at the beginning of next class, but I want to do as much as we can because I want to protect as much of your study day as possible. Yes? So we have done enough for you guys to do the 1B homework, so you should be fine on the 1B homework. It's still due next class, yeah. If there's 1 or 2 problems you're not quite sure of, just wait till we finish the notes and do them before the test. All right, can I turn the page? Anyone still copying this down? All right, example number 5 is blurry. Why? Suppose you roll 2 dice. Okay, this is compound probability, so we're looking at independent or dependent events. Suppose you roll 2 dice. What is the probability that you'll roll, excuse me, a 4 on the first die and an odd number on the second die? Okay, so these are independent events, right? The rolling 1 die has no impact on rolling the second die. So my 2 events are rolling an odd number, rolling a 4, and my second event is rolling an odd number. What is the probability of rolling a 4 on a 6-sided die? Just shout it out. 1, 6. What is the probability of rolling an odd number? 3, 6. You have to include the bottom number. So I'm going to multiply 1/6 times 3/6. This gives me 3/36, which simplifies to 1/12.
That's the answer?
That's the answer.
Wait, I was pretty close. Next to the 6.
The 3 next to the 6? This one or this one?
No, the other.
This one. Yeah. What's 1 times 3?
3, but like,
And then 6 times 6 is 36. So you're just multiplying fractions.
You multiply it all the way across.
Yeah. You remember? You guys all remember how to multiply fractions?
Yeah.
Okay. Yeah, so multiply across and simplify. Or I prefer to simplify and then multiply, but you can do it either way. All right. This is also something I changed on yours. So you're rolling 2 dice. What is the probability that you roll an even number and a number greater than 4? Do you guys feel like you can do this on 2 different dice?
So there's 12 sides.
So the 2 different dice. You're rolling an even number, and then you're rolling a number greater than 4. 2 different events. No impact. Independent events. Same equation. When you think you have your answer, please hold up your board. Yes, it can be simplified. Because of time, I'm going to give you guys 1 more minute, and then we will go over it. Yes? Nope, sorry.
What?
I don't think you did it over 6, because 6 times 6 is 36. So 6 times 6 is 36. Yep. 30 seconds, and I do apologize for rushing you guys. So your unsimplified fraction is correct, but you simplified it incorrectly. So it's not all right. Can you guys help her out? It's just the last step she's having trouble with. Yep. Okay, let's take a look at what you guys have. All right, ladies, here is the answer. Any questions on this problem? All right, I'm going to walk you through the next problem, and by then the bell's going to ring. I reworded this in your notes. Your notes, I believe, says you draw one card from a standard 52-card deck and record it. You repeat this process and draw a second card. What is the probability that both cards are aces if you don't replace the first one? What is the probability if you do replace the first one? All right, let's take a look at this. How many aces are in a deck of cards? 4. How many total cards are there? 52. So, we're doing the same thing. We're multiplying. But my second draw, if I don't put the card back, my probability changes. So if I drew an ace, now how many total cards are there? 51. And how many aces are there if I took one out? 3. So that's how I got 1 over 221. Now in this case, I simplified before I multiplied just to make the numbers a little smaller. Now, if I do replace the card, then it's just going to be 4 over 52 times 4 over 52, which gives me 1 over 169. And again, you are allowed calculators on this test, so you could multiply the fractions across and then simplify. I like simplifying first. All right, we'll pick it up here. Next class, you guys did a great job. Please do the 1B homework, and I will see you guys on Thursday. I'm starting to really like you.